Hello everyone, I'm Khalid and I'll be your instructor for this Python course provided by Learning while Practicing. In this video, we'll start going into some Python code and start writing some actually interesting statements and see what happens. So let's get started. So as we described in the previous video, I have just created a new project and created a new Python file in here so that we're ready to go and start writing our code. So we can start writing code in this space. So the first thing that we need to start with is to define variables. So what is a variable? A variable in any programming language is some location in memory that stores some specific value. And this value could change over the course of the program over and over again. So in order to define a variable in Python, it's very simple actually. Let's say that we need to store the value of 5 in some memory location. In order to do this, we need to name this memory location. We need to have some identifier in order to reference this memory location. So let's say that we name this as x, and then we just say x equals to 5. That's it. Here we have defined a variable called x, and this variable is a space in memory or a name for a space in memory that contains the value of 5. As you can see here, we don't need to specify any kind of type for the variable. Once we have assigned this variable x a value of 5, the Python interpreter automatically identifies this variable as an integer. So in order to see that, let's print the type of the variable. And in order to find the type of some variable, just type and x. So we run this. We can run, as mentioned before, we just click run, then elementary, and then we can find here that the type of this variable is an integer. Okay, sounds good. We can have also some other kinds of variables. Let's say that we have a string like the one we printed last time, hello world. So here we have defined a variable called y, and we have assigned the value of hello world to y. So as we can see here, this is a string. It means words, sentences, or few characters. And they are now stored at the memory location identified by the variable y. We can, of course, print y as we did before. We can run. We can just hit Control Shift and F10, and it prints hello world. We can also find out the type of this y variable. So print type of y. Let's see what would be the result here. And we can find here that the result is a string. So str is a string. Okay. Another interesting type of variables is the floating point variables. So let's say you have a variable called z, and this z is just 2.5. In order to store numbers like 2.5, some integer, and a fractional part, we need some kind of variables called floats. So if we look at the type of this variable z, we can find that is defined as float. So a float variable is some numeric value that has both an integer and a fractional part. Okay, so we have also some other interesting kind of variables called the bool value. So if we have, let's say, variable t, and we set it to false, and print type of t, run, we can find that t here is a bool. So a bool variable or a boolean variable is some variable that can take either the value of true or false. So either 1 or 0. It's very useful in some kind of application like flags. We'll see that later in the course. And this could be assigned either value of false or true. We'll also see later how we could store the result of some comparison operation into some Boolean variable. And you need to notice here that false here has a capital F, and it's not enclosed by double quotes or single quotes. It's just false. This is a keyword in Python that has the value false. So this is the boolean value false. You can also set it to true if we want to. And if we return the type, we still have the type true. Okay, sounds interesting. Let's look at some of the operation that we can do on variables. So let's look at the easy one. Let's look at the addition. So we have here x is 5 and z is 2.5. Let's do x plus z and just print out what would be the value of that. So the value is 7.5 as you would expect. So this is the basic mathematical operation. If we want to do multiplication here and run, so here's the multiplication value. Let's have another variable. Let's say it's say f, for example, and this value of f is 15. And let's say that let's reassign O to be 2. And we need to do some division. So we print f slash O. So the slash here is the division operation. And we run. Okay, so it's 7.5 because 15 over 2 is 7.5. So this is the real division operator. So it just divides these two numbers and just get the floating point value of that. If you want to just get the integer part of it, we have some other operator, which is double slash. And if we do double slashing here, we can get only 7, only the integer part of the division. Okay, let's move on to another one. We have this modulo operation. Let's say print f modulo O. And if we do this, we'll find that the value is 1. So what is this value? This is the remainder of the division of 15 over 2. So 15 over 2 is 7, and 7 multiplied by 2 is 14. So the remainder is here 15 minus 14, which is 1. So the modulo operation here returns the remainder of the division of this number over that number of f over o. So basically 15 over 2. So here that prints the remainder of division f over o. As we can see here in this example, this is 15 over 2. So 15 over 2 would be 7.5. So remainder here is 0.5 multiplied by 2, which is 1. So that's why we have the result of 1 over 8. Okay, so let's also look at some bit more complex expression. Let's say we want to print f plus z, let's say f plus o multiplied by x, and find out the result. So the result here is 25. So f was 15 plus o here is 2, and x up there was 5. And we can find that the result here is 25. But why is it 25? It is 25 because here we have something called the operation precedence. So some operations have precedence over other operations. So for this expression, the multiplication operation would be evaluated first. So O multiplied by x, which is 2 multiplied by 5, which is 10. And then after evaluation of this part, we add the result to f. So here we have 15 plus 10. So that would be 25. This is really important to note because in some cases you might get an unexpected output. You don't know why it is that. So if you really intended to do f plus o and then multiply the result by x, then we can use parentheses. So You can just write down the same operation again, or the same expression again. But if we want to change the order, we need to do f plus o first. We need to do enclose these into parentheses. So in this case, that would be 15 plus 2, and the result of that would be multiplied by 5. And let's see what would be the output. So that would be 85. So operation precedence is a very important thing to take into consideration. There are lots of tables that has the precedence of all operations of Python, so you can look it up on the official website, and you can find lots of resources about that as well to have the full precedence of all operations. Okay, so that was it for this video as a brief introduction to some of the programmatic approaches in Python or some of the statements in Python, and hopefully see you in the next video.
Hi, this is Joe from Learning While Practicing. For Chapter 2, we are going to see 3 different examples together. Let's start with the first one, Chapter 2, Exercise 1, Area with Input. So we are going to open this code right here in PyCharm, and it's constituted of simply 3 lines of codes and 3 lines of comments. So for the first line, we have here in the comment, prompt the user to enter a radius. And it's defined by radius equal eval input, and you have a string right here, enter a value for radius, and the parentheses that are closed. So what this does right here is that it's going to give the variable radius that we are creating here a certain value. Now, when I write eval and input, it means that I'm prompting the user to enter the value that he or she wants. Okay, so it allows the user to interact with the program. This is the way for the user to interact. It's not something passive as we have seen in the first example. It's something that will change the value, the output will change depending on the input that has been given. So when I put here enter a value for radius between quotes, it means that this enter a value for radius 2 point and the space are going to be taken as a string value. A string value means a series of characters. So it's not something that is going to be computed. It's not something that is going to be multiplied, divided, or subtracted, or addition, etc. It's something that is going to be simply as text. It's a text to tell my user what to do. Okay? Now, once my user has given me the value, I'm going to do the computation of the area. So here for the area, what I'm doing is actually I'm assigning to the variable area here, I'm creating a second variable in this program called area, which is equal to the product of the radius. The star here means a product. Radius, product, radius, product, a value 3.14159, which is actually an approximation up to 5 digits of pi. Okay, so it's actually r squared times pi, which is the formula of the radius of a circle. Okay, giving me the surface of that circle. So here the value radius is the value of the variable that has been input by the user. So I'm going to use this input from the user in that formula right here. So now that I have computed the area right here using this formula and using the variable radius, which was given a value from my user, I need to return to the user the value of area, because otherwise area is going to be calculated and the variable is going to be assigned, but the user will not know. Because if I don't use the print value, if I don't return this value to the user will not know what value the area has taken. So for the last line, I need to display the results. So by using the print function, actually the print function is to show something on the screen, is to give an output on the screen. So I'm going to print the following. And when I do my printing, as you can see, I'm going to have, first of all, a string right here between quotes, the area of the circle of radius. So meaning that here I'm giving actually a sentence to introduce my variable, and comma, I'm going to write the variable radius that I have right here, then is as a string, and finally area. So now if I try to run this program, let's see what it's going to give. We're going to open the file in a project. Okay, so we're going to close this one. I had it still open from last video. So now if we want to run what we have, we're going to choose the second one, chapter 2, exercise 1, area with input. Now, once we run the program is now waiting for us to give a value for the radius. So let's give a value of 5, for example, and we hit enter. So now that the area has been calculated, the printing line in the end gives me the area for the circle of radius 5 is 78.53975. So this is the result of my calculation of the area based on a radius of 5. So if I decide to run the program once more with a different radius, a radius of 7, for example, now I'm going to obtain a new area of 153.93791. So this is a first example that you have practically seen, and now you know how to give your user a command in order for him to give you any value that you want. So you can define actually more than one variable to prompt your user to give more inputs, and that's what we are going to see in further videos. The second example of chapter 2 that we are going to see together is about the time module in Python. So we are first going to open this code that we have right here. So the code starts by importing the time module. So the time module is actually a module in Python where functions related to time are predefined. And functions related to time can be very useful to extract the current time, to create a clock, to create a calendar, to create anything related to time functions that are needed for your program. So instead of having to redefine things from scratch, you can use this module, and it's a module that is already contained with Python itself. It's not something that you need to have as an additional module file. So the program here starts by importing the time module. And here we want to extract the current time. So in order to extract the current time, we are going to define a variable called current time and assign to it by the equal sign the function time.time with parentheses. So whenever you import a module with the syntax like this, import module, you need to write the name of the module, dot, and the name of the function. In case you want to get rid of this form of notation, you can, instead of writing import time, write from time import star, which means import all. And in that case, you can simply reduce here the notation from time dot time parentheses to time parentheses. Now, when I run the program like this, Python will understand that time with parentheses is actually a function contained in the time module. If I write import time only, I will need to specify every time I need to use the time with parentheses here function, I will need to specify the module before doing so. So I'm going to get back to the notation we were previously at. Okay. So now that I have obtained the current time, this allows me to get the current time. I want to divide it into seconds, minutes, and hours. So now that I have the current time, in order to get the seconds, I'm going to define a new variable called total seconds, and I'm simply going to take the integer value of current time, because current time is actually a value that is going to be in seconds with decimals of seconds, so with fractions of seconds. In order for me to get a complete number of seconds, I need to get the integer value of current time. So meaning it's a value that is not float, that does not have any decimals. Then if I need to get the current second at which I am, I need to do so by defining a new variable called current second. And by taking the total seconds that I have, I need to do a remainder by 60 because the seconds, they become minute every 60 seconds. So every time 60 seconds pass, I have a new minute. So in order to know at what second I am in my clock right now, I need to take that total number of seconds and do this operation right here. The percentage will actually give me the following. It gives me the remainder of this value by 60. So when I divide this by 60 and I obtain a remainder, this is what this whole syntax right here will give me. So for example, if I'm at the 60th second, I will obtain 0, meaning I am at the very start. So I have already been at 60 seconds. So there are no additional seconds because 60 seconds gives me 1 minute. If I'm, for example, at the 10th second, I'm going to obtain as a reminder 10 because I'm going to have certain product times 60 that has already passed plus an additional 10. So this is how I get the current number of seconds. Now, in order to obtain the total number of minutes, I will have to do the integer division of total second by 60. So the difference between this and this is that this one will give me a float value. It will give me a value with decimals, a value with something after the comma. But when I do a double slash right here, what it does is that it gives me only the integer value of this division that I have right here. So that way, now that I have the total number of minutes, I can extract from that the current minute at which I am. And actually, just as we have done for the current seconds, we are going to divide the total minutes using the percentage sign by 60, which is actually finding the remainder. This will give me back, return the remainder of total minutes by 60. Now for the hours, I will have to divide by 60 as well because every 60 minutes gives me an hour and with the integer value. However, for the current hour, I will have to do total hours with percentage 24 because every 24 hours I have a new day that starts. So we are going to run this program by going to File and open it as a project. We are going to discard the changes that we have done so far. We do not need to incorporate them to the program. And we are going to run it. So here, in case the program does not show right here, you simply have to go and select it right here. So now, once you do the run, it will show, okay, in case there's a problem with that, because sometimes it can happen. So we click on show current time, and here is the current time GMT that is being shown. So as you see, we have actually all of these values that have been carried out, but all that we are returning are the values, the variables current hour, current minute, and current seconds. Okay, we could have, for example, decided to print additional variables. So let's start doing that together. We are going to print, for example, total seconds. Then with a comma, meaning that we need something additional, we are going to print, or let's go to the line to do that, to have them one under another. We are going to print total minutes. So we need to be careful when we write the notation. So the good thing is that we have here a variable v near total minutes and a suggestion to what to write in order for us to avoid doing any mistake. And that's the advantage of using an IDE. And here we are going to print the total hours. So now that we have these three variables right here, in case I decide to run the program once more, you see now it gives me here the four returns, one about the total number of seconds, one about the total number of minutes, and one about the total number of hours. And of course, you're going to ask me, what is the starting point? Well, in Python, the starting point is actually from January 1 at midnight in 1970. So this is the starting point of the counter in Python. Of course, you could decide to do another counter that starts at any time you want. You can define that in programming, you can do almost anything you want. But here, in order for us just to show the current time, we do not need to do anything more than this. So you see, for example, these three that I have, actually, I do not really need to have them. They are not that meaningful as much as current hour, current minute, current second. But it was just to show you two things. Any variable can be accessed in the main program as long as we're not in a method that is private, which we're going to see later on in further chapters. And as long as I do not have any print or return or get value, which is what we define in method, we will also see that later on. As long as we do not have these syntaxes in front of the variables, they will actually not be revealed at the output. We really need to specify which variables we need to output. Otherwise, they will be stored in the memory, they will get values, they will be assigned values, but they will not be returned to the output unless I specify that this must happen. And now we still have to see together the third exercise for this chapter, exercise number 3. For exercise 3 of chapter 2, we are going to calculate the distance between 2 points and then represent it graphically using the turtle module in Python. So first we are going to open the code as we are doing with all the exercises using the PyCharm IDE. So here is the code that we have. So let's see how this code works and what we expect it to do. So first of all, we are going to import the turtle module since we need it to represent graphically our program. Then we are going to prompt the user for inputting 2 points of his or her choice. So as you know, each point has 2 coordinates, an x coordinate and a y coordinate. And here, instead of asking the user for different values, we are going to ask the users to input 2 values at the same time. So in order to assign for the first point x1 and y1 the coordinates at the same time, what we can do is simply write the variables separated by commas and then equal. So now with this syntax right here, Python understands that it needs to assign values for both x1 and y1. And here we start with the syntax eval parenthesis input parenthesis. Here we write a string of characters in order to indicate to our user what must be done, and we close both parentheses. So when this line of code will be run in Python, it will prompt the user to give an input for both x1 and y1. So basically what the user will do is, for example, write 3, 2, which will be x1 equals 3 and y1 equal 2. The same goes on for the second point. And once this is done, we now have the coordinates for point number 1 and point number 2. For this part, we now have to calculate the distance, which is given by the formula x1 minus x2 power 2, and the power is represented by a double star, and plus y1 minus y2 power 2, so a parenthesis here to make sure that all of this expression is taken to power of 2, as well as for here, and a parenthesis prior to that so that all of this is taken to the power 0.5, or if you want, square root. Now, the square root function does exist in Python, but we will see it later on when we study the math module together in the next chapter. And once we have calculated the distance, we need to return to our user the result. And since we are going to do that graphically, that's where Turtle is going to come in handy. First thing first, we are going to draw a line between point 1 and point 2. And in order to do so, as soon as Turtle starts, we need to rise our pen. So the pen needs to be up in order for us to go to the coordinate of the first point without drawing a line from the center where the turtle cursor is originally until point 1. So we raise the pen. Once the pen is raised, since we want to draw from x1 to y1, we will put the pen down once again. So here, if you see turtle go to, we have to mention the coordinates, and that's how we chose the coordinates of point number 1. Now, once the pen has been put down, we can go directly to the second point, but first we are going to write a text on the first point, and using the write function in the turtle module, we are going to write between quotations the string character point 1, which indicates that this is the first point. Then when we write go to x2, y2, since the pen is down, there will be a line that will be drawn from x2 to y2. And then we also want to point that this is the second point, the second point that we have that has been input by the user. So we will also use the turtle write point to. Now that this has been done, we want to move to the center of the line in order to write the distance, okay, the value of the distance. And in order to do so, we need to go to x1 plus x2 over 2, y1 plus y2 over 2, meaning right at the center of the line. But since we do not want to redraw anything from point 2 to the center, we need to raise the pen right here. And once we go to x1 plus x2 over 2, we can write the distance. And here, as you can see, here it's the variable that is going to be written, not a series of characters between quotes. And as you can see, the write function is not affected by the pen up or pen down because we are specifically saying that something must be written. So it does not matter whether the pen is up or down. There is no ambiguity there. And once we finish, we are also going to add the turtle dot done with parentheses in order to make sure we remain in the loop. So we remain with the turtle window open until we decide to close it, or more appropriately, until the user decides to close it. So now we are going to run this program by going to File and open it in a new project. So now that our program is open, we are going to run it. And we are going to do a test to see exactly what happens. So here I'm going to choose for the first point minus 150 and minus 100 for the coordinate of the first one. And for the second, I'm going to choose 150 and 170. And I run it. So you see here it has been run like this. And here is what you get. This is point 1, this is point 2, and this is where we are in the middle with the value of the distance. So you see, not only was I able to compute the distance, but I was able to represent it, and very quickly. That's the advantage of using Turtle, and that's the power of the Turtle module in Python, representing things pretty easily. So hope you enjoyed this tutorial so far, and I'll see you in the next videos.